Hi, in this video I will be describing the binary number system. We will contrast it with a decimal number system, and then we will see why it's important to know about binary. The binary number system is a number system with a radix or base of 2. This means it only has two symbols that can be used to describe any quantity. These symbols are 0 and 1. A single symbol is called the bit, which is short for binary digit. The decimal number system has a base of 10. Any quantity can be described by using 10 symbols. These symbols are 0 through to 9. Let's look at some examples of how any quantity is described with a decimal number system. A number can be described by a string of digits multiplied by the base to a certain power. For example, 1 equals 1, which is the digit, times 10, which is the base, to the power of 0, which relates to the position of that digit in a string. To make it more clear, let's jump to the last number, 517. This can be expressed as 5, which is the digit, times 10, which is the base, to the power of 2, which relates to the position of the 5 in the string. The same can be done for the 1 and 7, and if you evaluate that sum, you will see that it is indeed 517. The binary system follows the same rules except that we only have two symbols and that the radix is 2. So for example, 0 equals 0 times 2, which is the base in this case, and 0, which relates to the position. Jumping to the last number, 1101, we can see that it is 1 times 2, which is the base, to the power of 3, which relates to the position of that digit. Evaluating that sum will result in us relating this binary number back to the decimal number system. As seen here, 13 equals 1101. So why does this matter? The basis of all computing is binary. Usually computers have two logic levels. 5 volts represents a 1, or on, or true. 0 volts represents a 0, or false. The second point on this paper relates to the first. To harness any technology, such as microcontrollers, we must understand it. With better understanding comes better implementation. For example, if we use an 8-bit microcontroller, what does this mean? It means that a single register within that controller can store a maximum value of 8 ones. If you relate that back to the decimal number system, you'll see that it's 255. A more practical example is we have an Arduino with an analog to digital converter, which resolution is 10 bits. What are the maximum and minimum values that we have to work with? The minimum would obviously be 0, and the maximum is this string of 10 ones. If we decompose it as we did in other examples, we'll see that the maximum value that can be represented by 10 bits is 1023, or a shorthand of writing it is the base, which is 2, to the power of 10, which is the length of this number, minus 1.